In our previous lesson, we learned how to solve systems of equations through elimination by adding or subtracting the two equations together. Now, this is a very similar method, believe it or not, but it will require one extra step. That will require multiplication. So if you remember the lesson in 6.3, every time we had a system of equations, at least one, sometimes both, but usually just one of the variables have the same coefficient. Might be 4 and negative 4, 7 and 7, 2 and negative 2, negative 4 and negative 4, anything like that. But there are times there's a system of equations where the variables don't match anywhere. Now, in that case, one or sometimes both equations must first be multiplied number before the system can be solved by using addition or subtraction. Now, that means there's really just one step we have to do in these before we do the exact same method we did in 6.3, where we eliminate by adding or subtracting. Okay, on number 3, so since this is 2x and this is 1x, I'm going to multiply everything in this equation by 2. So 2 times 1x is 2x, 2 times 2y is 4y, 2 times 5 is 10. And just to put them together, I'm going to rewrite the first equation right below that. And since we have a positive 2 and a positive 2, they have the same sign and the same variable, so we will subtract them from both sides. 2x minus 2x is 0, 4y minus 3y is 1y, and 10 minus 6 is 4. I do apologize for the cough. So we get y is equal to 4. Now we can plug in 4 for any one of these y's, doesn't matter which one. I'm going to choose the second equation this time, go figure. So we get x plus 8 equals 5. I subtract 8 from both sides, and I get x is equal to negative 3. So our solution, our ordered pair to this system of equations, the place where they meet, the place where they're both true, is at negative 3, positive 4. Okay, 4 is similar to number 1 in the sense that you really could either manipulate the a's to match or the b's, up to you completely. I'm going to choose to manipulate the b's. Now, again, you could triple this equation so you had 3a and 3a, and that would work out fine. You could also double this equation so we have negative 2b and positive 2b. So 2 times 3a is 6a. 2 times negative b is negative 2b. 2 times 2 is 4. So we have a positive 2 and a negative 2. When they have different signs, we add them together. Different add. 1a plus 6a is 7a. 2b plus negative 2b is 0. 3 plus 4 is 7. So we'll divide both sides by 7 and get a is equal to 1. At that point, you can plug a into any of the three equations you see. This one looks simplest to me. So I'm going to plug 1 in for a right there. So we'll subtract 1 from both sides. And then we'll divide both sides by 2. So b is equal to 1. So we have the ordered pair 1, 1 that turns out to be the solution to this system of equations. So if you look at number 1, you'll see what I'm talking about. If I look at the x's, I have a 1x and a 4x. They don't match. I have a 10y and a 5y. They don't match either. So what I have to do is multiply either the top equation or the bottom equation by a number to make it so they do match. Now in this one, you have a choice, and either choice can work fine. You could decide, all right, I want to make this a 4x so it matches this one, so I can multiply everything in this equation by 4. That would be fine. Or you could say, wait, I could just double this equation, double the 5 to make it a 10, then I could combine those two equations. Now, you can do either one. I'm going to choose to double this second equation. So just to keep them together, I'm going to first double everything in this equation. So 2 times 4x is 8x. 2 times 5y is 10y. And 5 times 2 is 10. And just to make it easier to see what we're doing, I'm going to rewrite this equation, not changing anything, just rewriting it down here. So now we know we focus on just these two equations. Now this one is the exact same as the one we started with, but this one is an adjustment to the one we had in the original because we doubled everything. Now we're allowed to do that, just like when we solve for x, we're allowed to add, subtract, multiply, or divide both sides by the same number. We're allowed to do that because these are still the same as long as both sides, all the terms, were affected the same way. So now this does look like a problem we had in the previous section because both the y's have a 10. Since they both have a positive 10, that means they have the same sign, so we will subtract the two equations. 8x minus an understood 1x is 7x. 10y minus 10y cancels out. And 10 minus 3, don't forget to subtract all of them, 10 minus 3 is 7. So I can divide both sides by 7, and I get x is equal to 1. Now you can pick any one of these equations to plug the 1 into to solve for y. Now obviously this equation and this equation are identical. Now these two are not identical, but they do end up equivalent because all we did was double everything to get this one. So you can plug it into any equation you see here and solve for y. I'm just going to pick the top one. I'll plug 1 in for x. Then I'll solve for y. So I'll subtract 2 from both sides. Sorry, that's not true. I'll subtract 1 from both sides. I was getting ahead of myself. 1 minus 1 is 0. 3 minus 1 is 2, and I was already thinking about that 2. I think is why that showed up. Then we'll divide both sides by 10. So notice this does not come out to a whole number. It comes out to 2 over 10, which we can reduce by dividing both of them by 2 and getting 1 over 5. So our solution to this differential equation is 1 and 1/5. Okay, now number 2 honestly represents about the hardest we'll get because on number 1, we were able to just multiply one of the equations by a number to make things match up. And that will happen plenty of times. But there will be times like number 2 where I can't just multiply 3 by a whole number and make it equal to 2, or vice versa. I can't just multiply 2 by a whole number and make it equal to 5, or vice versa. So if you look back here, it says in such cases one or both of the equations must be multiplied by a number. So here it's truly up to you whether you want to make the x's match or the y's match. I don't really think one makes any easier or harder than the other. I'm just going to choose the x's. So I got to think, okay, I can't turn a 2 into a 3. I can't turn a 3 into a 2. But what number did I turn both of them into? In other words, what's the lowest number that both 3 and 2 could go into evenly? Well, that would be 6. So if I double this equation, everything on both sides by 2, I'll get a 6x. And if I triple this equation, everything on both sides, I'll get 3 times 2x, which is also 6x. So I've got to distribute this 2 to all three terms. So 2 times 3x is 6x. I'm doing the top equation right now. 2 times 2y is 4y. 2 times negative 7 is negative 14. So this is the result of me doubling the top equation. Now when I triple the bottom equation, 3 times 2x is 6x. 3 times 5y is 15y. And 3 times 10 is 30. So now that I've multiplied both equations by a number, I have a situation like what we had in section 6.3 where they do have the same same coefficient, so I can eliminate them now. Both of them are positive 6. When they both have the same sign, we subtract. So 6 minus 6 is 0, eliminating the x terms. Negative 4 minus negative 15 is the same as negative 4 plus 15, so this becomes a positive 11y. Okay, negative 14 minus 30 gives us negative 44. So then we divide both sides by 11, and I get y equals negative 4. And just like I said in number 1, you can choose any of the 4 equations you see written there to plug in negative 4 for y. It'll work for all of them. I would tend toward using the originals because they have smaller numbers, but you could get it correct plugging negative 4 in for y for any of the 3. I'll just do in the top one like I always do. So I plug in negative 4 for y. Negative 2 times negative 4 is positive 8. Then I subtract 8 from both sides. I get 3x equals negative 15. Then I divide both sides by 3, and I get x equals negative 5. So our ordered pair, that is the solution to this system of equations, is negative 5, negative 4. Now 5 and 6 are the tricky kind, like number 2, but I would encourage you to pause the video and try them on your own. So whether or not you try them on your own, we're now going to go through these. So just like before, we can choose which ones we want to make match. So I could choose to match the x's. The lowest number that 4 and 6 go into evenly is 24. So I can multiply these two to make both of them 24. Or the lowest number that goes into both 5 and 7 is 35. So I could multiply in order to make this 35 and this 35. Either way will work. I'm going to choose to eliminate the x's. So I'm going to multiply everything in this term, or this equation, by 6, giving me 24x plus 30y is equal to 36. So I multiplied everything in the top equation by 6. I'll multiply everything in the bottom equation by 4, so I get 24x minus 28y equals negative 80. And since they have the same sign, positive 24, we will subtract. Same sign, subtract. 24 minus 24 is 0, so the x's are eliminated. 30 minus a negative 28 is really 30 plus 28, so that's 58y. And then 36 minus negative 80 is really 36 plus 80 for 116. Then we divide both sides by 58. And we finally have one of the values for an ordered pair, and it is y equals 2. So you can plug this 2 in for y into any of these 4 equations and solve for x. I'll just go back to my default and plug it in the top one. 5 times 2 is 10. Subtract 10 from both sides, get 4x equals negative 4. Then divide both sides by 4, and you get x is equal to negative 1. So the ordered pair that works for both of these, the place where they meet, is negative 1, positive 2. Okay, last one. I'm going to try to go through this one quickly. Again, you can choose whether you're going to make the 3 and the 2 both turn into 6's, or whether the 6 and the 4 are going to turn into 12. So just for a little variety, let's make the 6 and the 4 both turn into 12. So to make a 6 turn into a 12, we need to multiply by 2. 3x times 2 is 6x. 6 times 2 is 12. Negative 3 times 2 is negative 6. So again, that is the top equation multiplied by 2. Now, to make the 4y a 12y, we've got to multiply this one by 3 all the way across. 3 times 2x is 6x. 3 times 4y is 12y. And 3 times 30 is 90. So this one actually turned out to be one that we could eliminate the x's or the y's, because even once I multiplied intending to eliminate the y's, I ended up with the same coefficient for x. And so at this point you could pick, you could say, okay, I want to eliminate the x's. They both have the same sign, so I'll subtract the two equations, and that'd work out fine. Or you could say, I want to eliminate the y's, which is what I'm going to do. That's a negative 12 and a positive 12. So they have different signs, and when they have different signs, you add them together. 6x plus 6x is 12x. Negative 12 plus 12 is 0. Negative 6 plus 90 is 84. So we divide both sides by 12. We get x equals 7. And then I can plug 7 into any one of these four equations for x and solve for y. We'll do the second one just for variety. So I plug in 7 for x. I need to solve for y. I get 14 plus 4y equals 30. Subtract 14 from both sides. And I get 4y equals 16. So we divide both sides by 4 and get y is equal to 4. So our final answer is the ordered pair 7, 4.